948. Decide if the following statements are true or false. If they are true, explain how you know. If they are false, provide a counterexample. All right, so the first statement is if a quadrilateral has two sides that are parallel and two sides that are parallel and two sides that are congruent, then the quadrilateral must be a parallelogram. Okay, so when I read this problem, I initially read it and I think I have something like this, parallel and congruent. But when you go back and you read that, it says if a quadrilateral has two sides that are parallel and two sides that are congruent. It's not saying they're the same side. So then you could have something like this. Two sides are parallel and this side is congruent to this side. So in this instance, it's a isosceles, whoopsie, let me write that better, isosceles trapezoid. And yeah, so this would be false, and this would be my counterexample. So we could say that's false. All right, so then B says, if the interior angles of a polygon add up to 360, then the polygon must be a quadrilateral. Well, we've learned that n minus 2 times 180 gives us the sum of all the interior angles of a quadrilateral. So if we have 4 minus 2 times 180, that's going to be 2 times 180. So all those angles add up to 360 in a quadrilateral, and that will be true all the time. All right, so then we're looking at C, and it says if a quadrilateral has 3 right angles. Okay, so quadrilateral has 3 right angles. Well, these are add up to 270, and so this angle right here has to be 90 degrees. So because it has to be 90, the only shape that we know that has 4 right angles is a rectangle. So this would be a true statement. And D says if the diagonals of a quadrilateral bisect each other, then the quadrilateral must be a rhombus. Okay, so if I have some parallelogram, so these two, the diagonals bisect each other, these diagonals bisect each other. This is a rectangle that I've drawn, and so in a parallelogram, the diagonals bisect each other. So in all parallelograms, diagonals bisect each other. But just because they bisect each other doesn't tell us it's a rhombus. To be a rhombus, the diagonals must be perpendicular. Perpendicular. There we go. Perpendicular. So this shape, when the diagonals bisect each other, is a parallelogram.